Hello everyone and welcome to my channel Ghiloo once again. So this is exercise 5.5 of Continuity and Differentiability. Here I'll be solving all the questions. I'll be solving the first few questions in a methodological way, and after that I will just guide you with the process. So without any further delay, let's get started. Coming to question number 1. See, here we need to differentiate the following functions from 1 to 11. The first function is cos x times cos 2x times cos 3x. Now you can easily solve it by UV rule, by assuming one part as u times v, and once again inside this u you will be having two functions, hence 2 times multiplication rule should be applied. But what if we could do it in a much more easier way? That's what we will be doing by logarithmic differentiation. Remember, when there are complicated terms like this in question number 2, in question number 5, 7, you are seeing there are complicated terms which are not otherwise solvable by normal differentiable methods, or it would be very lengthy and time consuming. So to shorten this, we use a logarithmic method of differentiation. How is that? Let's see. So in question number 1, we assume y to be. So now what we'll do, we will be taking logarithm on both sides. So it will be log y is equal to log of cos x times cos 2x times cos 3x. As you know, the rule of logarithm is log of x times y times z gives you log of x plus log of y plus log of z. As you know this very well, I'll be applying the same here, log of cos x. So this is our log of y. Now we will be differentiating this with respect to x. So what is the benefit of this? We'll be seeing soon. This is going to be by chain rule. You know that log of x, the differentiation of log of x is 1 by x. You know this well. I'll be using it here in the form of chain rule. So this will be 1 by y times dy by dx, that is equal to log of cos x will be 1 by cos x times the differentiation of cos x with respect to x, that is minus sin x, plus 1 by cos 2x times the differentiation of cos 2x with respect to x, that is minus 2 sin 2x, and finally plus 1 by cos 3x minus 3 sin 3x. If you arrange it, you will be getting dy by dx is equal to, this is 1 by y, so you can easily put it that side, that will be y times minus sin x by cos x. Now you know that sin x by cos x, sin 2x by cos 2x, sin 3x by cos 3x will be tan x, tan 2x and tan 3x respectively. We take the minus out of the expression and put the value of y. So y, as we know, it is cos x times cos 2x times cos 3x, as we have assumed it. This is going to be tan x. So this is our expression. In this way we will be solving all the problems. So in question number 2, here I'll be pretty direct. Question number 2, here it is root of something, so we assume y to be this expression. Now if we add logarithm to the following expression, we'll be getting root of this whole thing. Root of this whole thing means this whole thing to the power half, and if we take log of y, I'll be getting half in front. So it will be half log of x minus 1 x minus 2 by, as you know, the rule of logarithmic differentiation, and further you know that this is log of something by something, so you can divide this further by log of x minus 1 x minus 2 minus log of x minus 3 times x minus 4 times x minus 5, and further you can break it to make it very easy, that is log of x minus 1 plus log of x minus 2. As log of uv comes out to be log of u plus log of v, this is minus log of x minus 3 minus log of. So I hope you are clear with this, and now you can differentiate it very easily as the previous. So you will be getting 1 by x minus 1 plus 1 by x minus 2, like that. So the final answer, as you will get it, is very simple. The final answer dy by dx will be y by 2 times 1 by x minus 1 plus 1 by x minus 2 minus 1 by x minus 3 minus 1 by x minus 4 minus 1 by x minus 5. Now you can put the value of y and you can arrange this if you want, or you can keep it like this. There is no harm in it. Coming to the third question, we have log of x to the power cos x. So obviously we'll be assuming y to be log of x to the power cos x. Okay, if we differentiate the following expression, it would be very complex, so we won't make it so complex. What we'll be doing, I'll be taking log of y, log to the both sides, and you'll be getting log of y equal to cos x times log of log x. This becomes a simpler expression. The exponent comes to the product here as a normal coefficient. So now I'll be getting 1 by y dy by dx. This is simply UV rule. So let us put cos x once and let us differentiate log of log x. Log of log x is 1 by log x times differentiation of log x, plus let me keep log of log x here as it is, times differentiation of cos x is minus sin x, and hence you can arrange this like this. Okay, now question number 4, just see this question because this is of a different kind. Here it is x to the power x minus 2 raised to the power sin x. Let it be y. Now see, if you want to differentiate it, there is no direct logarithmic way to this. If you want to differentiate it, you will be getting d by dx of x to the power x minus 2 raised to the power sin x. That will be equal to d by dx of x to the power x minus d by dx of 2 to the power sin 2x, sin x, 2 raised to the power of sin x. Now you know that you can differentiate both of them separately. If you can differentiate both of them separately, your job is done. So let this be u, let this be v. Now you take log of u is equal to x log of x, because u equal to x to the power x, and because v is equal to 2 raised to the power sin x, you get log of v is equal to sin x log 2. Now this is pretty easy to solve. This will be 1 by u du by dx, and here the uv rule will be applied, so that is x by x plus log x, and here log v, this is 1 by v times dv by dx, that is equal to, since log of 2 is a constant, I'll be having log of 2 cos x. Now you can subtract this because you will be getting both du by dx. This is u, that means x to the power x times 1 plus log x, and you will also be getting dv by dx, that is v. V means 2 to the power sin x times cos x times log 2. So now you can be subtracting both of these expressions because this is what is needed. In this way, when there are any additions or subtraction between this kind of functions which needs logarithmic treatment, you can break them down into further 2 more different fractions to solve it differently. Now coming to question number 5, in the same way we have the following expression, x plus 3 whole square. And the point is, if we want to solve this, we can solve this in a complicated manner by directly differentiating, applying chain rule, but by applying the logarithmic form of differentiation, the thing will be much easier. So this is a product of 3 different functions, so we can separate the functions in the form of addition, that is x plus 3 whole square plus, and hence we can apply differentiation on both sides, that is this will be equal to 4 by x plus 3 plus 3 by x plus 4 plus 4 by x plus 5, and then you can put y to this side to obtain dy by dx. As simple as that. Similarly with question number 6, I think I need not to go more on question number 6 because it is almost the same as question number 4 was, just the function is a bit different here. Once again, by the logarithmic rule, you will be assuming this to be u, you will be assuming this to be v. You will be taking the log of both of them and you will be solving them. You will be finding du by dx and dv by dx. Finally, you will be adding this to get the differentiation of this entire function, which you can assume to be y. Alright, so basically the rest of them, that is question number 7, 8, 9, 10 and 11 are to be done in the same way. There is not a bit of difference, just you need to apply. See here, since there is some summation of 2 different functions, so you need to assume one to be u and another to be v. You need to apply logarithm on both sides and solve du by dx, solve to find du by dx and dv by dx respectively, and then you need to add du by dx plus dv by dx to get d by dx of u plus v. This is the entire thing that you have to do throughout all these problems. So I think I need not to explain this again and again. I need not to solve this again and again. You are capable enough to solve these simple problems. If you have any kind of problem, please feel free to use the comment section. So this is of the same type but of a different form. From question number 12 to 15, we need to find the dy by dx again. Now we can differentiate it directly and find dy by dx, but the problem is these are not normal functions. So once again, here is a sum present. So in question number 12, I'll assume u to be x to the power y and v to be y to the power x. I'll be solving du by dx and dv by dx individually. So what is du by dx? For that I need to take log of u. Log of u is equal to y log of x, and here log of v is equal to x log of y. Let me differentiate each of this with respect to x. See, you can differentiate it with respect to y as well, and that won't change any of the answers. That would be the same. I go by x. So differentiating this, I'll be getting 1 by u du by dx, that is equal to y times d by dx of log x, that is 1 by x, plus log x times dy by dx, dv by dx, that is equal to x times log of y, the differentiation will be 1 by y dy by dx, plus log of y, and the differentiation of x is 1. So this is going to be our du by dx and dv by dx. Here I can multiply the whole expression with u and v respectively to get it. Now my point is, I want to differentiate this. So let me differentiate this both sides with respect to x. That gives me d by dx of x to the power y plus y to the power x is equal to d by dx of 1, that is equal to 0. Hence I get this as du by dx plus dv by dx, because this I had assumed to be u and this I had assumed to be v, that is equal to 0. So basically what we have is du by dx, that means u times y by x plus log x dy by dx, plus v times, because dv by dx is v times the entire expression, that is x by y dy by dx, plus log of y, that is equal to 0. So now what is u? U is x to the power y. So x to the power y times y by x plus x to the power y times log of x dy by dx, plus v is y to the power x times x by y dy by dx, plus v means y to the power x log y, that is equal to 0. So this is basically equal to x to the power y minus 1 times y plus x to the power y log x dy by dx, plus this is going to be y to the power x minus 1, x minus 1 times x dy by dx, plus y to the power x log of y, equal to 0. Simple enough. Now you just take dy by dx from this expression common, and hence you find dy by dx like this. Now with question number 13, this is going to be much easier. Here you need to find the differentiation of both this. You need to differentiate both the sides either with respect to y or with respect to x. I am going with x because I already have done this just in question number 12. It is already done, so it won't be any problem for me. So I'll be getting the differentiation very easily. For me it will just be u y by x plus log of x dy by dx, plus that is equal to v times x by y dy by dx plus log of y. So just this both are equal in this case, and hence you isolate the dy by dx term and find the dy by dx. Very simple. Similar is with the case of question number 14 and question number 15. You got to differentiate both the sides, and that will be the answer. In question number 15, I don't think any uv assumption is necessary because it is pretty direct. If you differentiate both sides with respect to x, you will be getting this as the product rule, that is x times dy by dx plus y times dx by dx, that is 1, that is equal to e to the power x minus y. Is e to the power x minus y times the differentiation of x minus y, that is the chain rule. So differentiation of x minus 1 is y minus dy by dx, and hence you can isolate the dy by dx to find dy by dx, that is x dy by dx plus y, that is equal to e to the power x minus y minus e to the power x minus y dy by dx. You take it to this side, you take y to this side, and hence you isolate the dy by dx and find it. So I hope you have no problem up to question number 15. Now coming to the last set of 2 questions. Coming to question number 16, in the same way we have this function which is a product of 4 functions, as we can see, and we need to find the derivative of it and hence find f dash 1. That means the derivative of it at x equal to 1. It's very simple. It's best to approach by the logarithmic concept. So you can assume y to be this function. What you have to do, just you need to take log of both sides. And now when you differentiate it, you will be getting this as 1 by 1 plus x plus 1 by 1 plus x square times 2x plus 1 by 1 plus x to the power 4 times the differentiation of 1 plus x to the power 4 is 4x cube plus 1 by 1 plus x to the power 8 times differentiation of this is 8x to the power 7. And so dy by dx is equal to y times the entire thing. So now you can easily put x equal to 1 here, since y is equal to this expression. You can put x is equal to 1 here, so you will be getting 2 into 2 into 2 into 2, that is 16. So 16 times, if you put 1 here, you will get the result. So question number 16 is done, I hope. In question number 17, it is very easy. We need to differentiate in 3 ways mentioned below. First is using the product rule. Repeat this, you can easily do it with the product rule. By expanding the product to obtain a single polynomial. Yeah, here is going to be 9 expressions in the first case, because we'll be expanding it and there are 3 terms in each of the expression. So that is x square minus 5x plus 8 times x cube plus 7x plus 9. So how to multiply? First with x square times x cube, then x square times 7x, then 9, then minus 5x times x cube, this, and then finally 8x cube, 8 times 7x, and 8, 9, 72. That's all you are going to find it. So this is 8th class algebra. I hope you won't have any problem. After arranging that, you will have a polynomial expression, big polynomial expression. You just have to differentiate it. That's all. And lastly, you need to do it by logarithmic differentiation. By assuming log of this, you will be separating these 2 terms and you will be calculating both of the results. And then you have to comment on whether or not they give the same answer or not. Obviously, since all the methods are equally logical and equally proven, there is no reason why they will give different answers. So they both will give the same answers. Coming to the last question, question number 18. This is the easiest of all. U, v and w are functions of x we are given. So we need to show that the multiplication of 3 of these functions will give rise to this. Now we need to show it in 2 ways. Firstly, by repeated application of product rule. Let me show you once the repeated application of product rule. This is d by dx of u times v times w. Let me assume u times v to be let me suppose p. So that is d by dx of p times w. So that is p dw by dx plus w dp by dx. Now p I won't disturb. Let me keep p as it is, dw by dx plus. Now w times dp by dx. That is d by dx of p. P is u dot v. So that is equal to u v dw by dx plus w times. Now this I am going to do it another in a repeated product rule. So that is going to be u times dv by dx plus v times du by dx. And that's how you get the result, by repeated application of product rule. And secondly, by logarithmic differentiation, this is as easy as hell. You can do it just easily. If you still have any kind of problem, please feel free to use the comment section. I'm saying again and again, I hope that you are capable of doing, and you will be capable of doing all the problems by yourself. So let us meet in the next video. Today let's keep it up to this. Thank you very much for watching this video.